Reagents and sites of organic reactions. There are two reagent or sites of organic reactions where they are called electrophile and nucleophile. Electrophile is electron deficient species which accept an electron pair from a nucleophile. So electrophile must react with nucleophile. Nucleophile must react with electrophile. There's no electrophile react with electrophile, no. Electrophile means electron loving. Can be either neutral or positively charged. Why positively charged? Because it is electron deficient. So usually if it has less electron, it is positive. Nucleophile, electron-rich species that can donate a pair of electrons to form a bond. Nucleophile means nucleus loving. Nucleus loving, nucleus, we know that nucleus consists of proton, positive. So when electron-rich, nucleophile is electron-rich, has high electron density. So that's why it loves the proton. Nucleus, proton, positive. Nucleophile love positive. So that's why it means nucleus loving. Can be either neutral or negatively charged. Electron-rich, so usually negatively charged. All molecules or ions with a free pair of electrons or at least one pi bond can act as nucleophile. Makes sense, free pair of electron because electron rich. Free pair of electron. One pi bond, double bond. In single bond we only have 2 electrons, but in double bond you have 4 electrons. That's why any molecule which has multiple bonds is electron-rich species or nucleophile. Example of electrophile: Lewis acid, oxidizing agent, and polar molecule. So Lewis acid is electron pair acceptor. For example, AlCl3, we know that AlCl3, this Al is bonded to 1, 2, 3 Cl only. So Al only has 6 bonds. It's not octet. Sorry, not 6 bonds, 6 electrons. It is not octet. So that's why it is electrophile, electron deficient, Al. The Al in AlCl3 molecule, this Al is the electrophile, electrophilic site, because this Al is not octet, it is electron deficient. Same goes to FeCl3, only bond to 3 single bond, has 6 electron in total, it's not octet, so electron deficient, electrophile. Cations and carbocation, these two are electrophiles because cation positively charged, carbocations positively charged. Oxidizing agent Cl2, Br2 are the example of electrophile. Polar molecule HCl, HBr. The H part can be electrophile. Delta plus, the H part. Example of nucleophile, Lewis base, electron donor. We know that nucleophiles are electron-rich molecule. So when it is electron-rich, it tends to donate electron. Lewis base, electron donor. Anion, negatively charged. Carbon ion, negatively charged carbon. Electron-rich. Molecules with lone pair, electron-rich. Pi bond molecules such as alkene, alkyne, aromatic range. So multiple bond, these three have multiple bond. You have multiple bond, they are electron-rich site. Because multiple bond, one single bond, 2 electron. If you have multiple bond, you have more number of electron. So nucleophiles, electron-rich. Functional group and reactivity. Functional groups create reactive site. So reactive site is at the functional group, means the functional group is where the reactive site is. So chemical reaction usually happen at functional group because functional group is reactive. Electron-rich sites react with electron-poor site, mean electrophilic site. Electron-deficient site reacts with electron-rich site. Molecules with low electron density around a polar bond. So usually electrophilic site usually can be found in carbonyl, haloalkane, and hydroxyl compound. Where is the electrophilic site? At the carbon part, not all these, not C double bond O as the electrophilic site. No, the carbon part is the electrophilic site because O part is electron rich. O is more electronegative. So the oxygen tends to attract these electrons from these two bonds, makes this O more negative, makes this O electron rich. But when we talk about electrophilic site, we have to find where the low electron density. So it's at this carbon, delta plus. The electron that is attracted by O makes this carbon delta plus or slightly positive. So the carbon site in carbonyl is electrophilic site. Same to haloalkane. Haloalkane group 17, X group 17, more electronegative than carbon. So the haloalkane atoms tends to attract the electron in this bond. So two electrons in this bond is attracted to this haloalkane atom, makes this carbon delta plus or slightly positive. So this is where the electrophilic site, not X, the carbon is where the electrophilic site. Means carbon in haloalkane. Same goes to carbon in hydroxyl compound. O delta minus, so it attracts electron in this bond, makes this carbon slightly positive. So electrophilic site is the carbon in the hydroxyl compound. Nucleophilic site, molecule with lone pair or with pi bonds. So if you look at the molecule with lone pair, nucleophile, we know electron rich. So lone pair electron rich, here electron rich because negatively charged. Obviously negatively charged is electron rich, and pi bond or multiple bond electron rich. That's where nucleophilic sites are.